what do these things have in common? Magma, salt, gems, snowflakes, chocolate. All of these have a crystalline structure. Today on Learn, Dream, Do, we'll be exploring crystals. Wait a minute. Chocolate is a crystal. Yep, you heard that right. Crystals have molecules, atoms, or ions that are connected to one another in an organized pattern. This is called a crystalline structure, and that structure repeats over and over. The molecules in chocolate are arranged like this, and this is also why chocolate gives that satisfying snap when you bite into it. Science is tasty.
Most of us probably think salt crystals are round, but when we zoom in closely, we can see that salt is actually millions of tiny crystal cubes stuck together.
Try this. Sometimes crystals take a very long time to grow. However, in this experiment, we're going to grow some overnight. These are the supplies that we'll use for today's experiment. I'm going to use half a cup of hot water, a glass jar, half a cup of Epsom salt, some pebbles or sand, a spoon, and if you'd like, you can use some food coloring. I'm going to take my glass jar and I'm going to go ahead and pour my Epsom salt in first. And remember, whenever you're making this, you want a 1-to-1 ratio. So if you use half a cup of the Epsom salt, you want half a cup of water. If you use a whole cup of Epsom salt, you want 1 cup of water. Next, I'm going to take my hot water and pour it in. I use my microwave to heat it up, but you can use hot tap water as well. And now I'm going to stir until the Epsom salt is dissolved. Okay, my Epsom salt has mostly dissolved, so I think I'm good there. It may not dissolve completely, but get it as close to as possible. I'm going to add my sand and my pebbles in. The reason I'm doing that is because crystals need some sort of imperfection to grow. It needs some sort of anchor basically to grow, so I'm going to put that in there. I'm also going to add a couple of drops of the food coloring in, so hopefully my crystals will look purple. Okay, everything is nicely incorporated and stirred. I'm gonna go ahead and put this into my freezer for 10 minutes. And once it's cooled for 10 minutes, I'm gonna move it into my refrigerator and let it sit overnight. And we'll take a look at what forms overnight. It has been about 24 hours and I have pulled out the crystal solution from the refrigerator. Let's go ahead and pour out the extra liquid. And be careful because some of the crystals may be loose. So I'm gonna try very carefully not to pour out any of the crystals. Here's a close-up look at the inside and the crystal structure that has grown overnight. Get creative with this experiment and see if different factors change the size of crystals that you get, such as using a different color of food coloring or using different sizes of pebbles and sand grains.
Crystals have been observed by scientists for many reasons. A scientist's job is to observe what is around them and stick to the facts. They can't add to the story or change what they actually see. A great tool for scientists is scientific drawings. In order to be a good scientific drawing, it must be accurate, it must be big, colorful, detailed, and explained. Let's go ahead and look at some scientific drawings versus some symbolic drawings. Remember, scientific drawings will have all of those features, while a symbolic drawing might tell a story. Which of these drawings of an elephant is the scientific drawing? You're right, it's the one on the right with the bones. As you can see, it's accurate and detailed. Which is the scientific drawing? You're right, the one on the left is more detailed and has accuracy. Which of these images are scientific drawings? Oh, it was a trick question. They both are. You don't have to be a professional scientist to do a scientific drawing. I challenge you to go outside, explore the rocks and crystals around you, and try and describe it using a drawing. Remember, good features of scientific drawings are accuracy, clearness, colorfulness, details, and if it is explanatory. Have fun!
I'm here with Kimberly Wagner from the Perot Museum. Kimberly, can you tell us a little bit about where you are right now? Hi, everyone. Yes, I'm Kim, and I'm the Gems and Minerals Director here at the Perot Museum, and I am in our Gems and Minerals Hall, and I'm actually standing right in front of our amethyst geode, which we've nicknamed the Grape Jelly.
So Kim, can you tell us a little bit about what is a crystal?
Sure. So I think for a lot of us, when we think of a crystal, we think of something that we might get from a rock shop, like we buy one of those small geodes and they crack it open and then there's those beautiful crystals on the inside, similar to what we see in our beautiful grape jelly geode behind us. And what makes a crystal is that it's a solid and it has a defined structure. And when I say defined structure, what I mean is it has this regular repeating pattern. Think of like a cube or maybe the 6 sides of a snowflake or something along those lines. That's what we mean by this defined structure. What's important to keep in mind is that when we talk about gems and minerals, they are crystals. But not all crystals are gems or minerals, because a crystal can also be organic. And when I say organic, what I mean is that it came from a living thing. So we think about maybe sugar. There are sugar crystals, but sugar comes from a plant, so therefore it is not a mineral.
Very cool. Okay, so we've got crystals and we have gems and we have minerals, and they're all sort of related, but they're all slightly different in their definitions, right?
They are. It's just, I think it's important to keep in mind that, as I was saying, like all minerals are crystals, but not all crystals are minerals. Because when we talk about minerals, there are 5 things that make a mineral. The 5 things that make a mineral are that it's a solid, it's inorganic, and when I say inorganic, I mean that it was never living. It's naturally occurring. It has a defined chemical composition, which I know that's a lot of words, but what I'm talking about here is if we think about the periodic table and all of those elements that are on there, that is what's making up the chemical composition of the mineral. So right now, they all disappeared, but we have our periodic table. So if I click on diamond here, it's made up of just one element, carbon. But then if I click on, say, emerald, we've got a few. We have aluminum, beryllium, oxygen, and silicon. And then if we go to, say, let's see, a fun one. Tourmaline, we have a lot of elements that go into tourmaline. We like to call tourmaline the kitchen sink because there's just so many elements that can fit in there and go in there. So that's the chemical composition. And then what we were talking about before with it being a crystal, that's the 5th part, is that it has a defined crystalline structure or that regular repeating pattern happening. So those are the 5 things.
I have another question, Miss Kim, if you don't mind.
Of course, I'm ready.
Can you tell us how crystals grow?
Minerals can form in different environments and through different geologic processes. Take, for example, the eyes of Africa here. This is quartz, which is the white, and the green/black is the mineral fluorite. This formed when over 150 million years ago in Africa, a volcano erupted, and then the crater caved in and water rushed in that was rich in fluorine, which is an element and one of the elements that makes up fluorite. And then it slowly started to cool and the quartz and then the fluorite started to crystallize.
That's so cool. All right. And then we've got another couple of things we want to see, right?
Yes.
Excellent. Different. Can you tell us a little bit about some of the other crystals in the Perot Gem Hall?
I'm standing in front of our birthstone display, which showcases the rough and cut for each month. Now the rough is the mineral and the cut is the gemstone.
So we're almost done with our tour with you today, Kim. Can you show us the very newest thing that you'll have?
Oh, yes. This is quite spectacular. It is called the Dragon's Lair Gold, and it's 63 pounds, and just the gold is 63 pounds. And if you look at the very, very top of the piece, it looks like a dragon's head is emerging from the gold. So that's where it got its name. And if you guys come, which I should say that we are open Thursdays through Sundays right now. So you can go online and see the hours for each of the days and also reserve tickets. But if you come, there's also a bunny that's hidden in the piece. So you can try and see if you can find the bunny.
That is so cool. Well, now I definitely want to go down there and see.
Please come. We've got some incredible specimens on view.
Thanks so much for an awesome virtual tour today, Kim.
My pleasure. I love talking about the pieces in the hall.
Absolutely. And we'll be seeing you next time. Thank you.
Earlier, Ian showed you how to make salt crystals overnight. Now let's make sugar crystal candy that you can eat. It takes a little longer, about a week, but it's still not nearly as long as it takes to make real crystals.
Here's what I used when I set it up last week. 1 cup of water, a clothespin, a wooden chopstick, or you could use a popsicle stick, a glass jar, 2 cups of sugar, and a couple drops of food coloring. Now we want the stick to hang in the jar about 1 inch from the bottom. Clip the clothespin so it goes across the top of the glass and keeps the stick in position. See how it looks like it's floating? Now set those aside while we use the stove to heat up the water and sugar. Make sure you have a grown-up help you. Pour the water into the pot, turn on the stove, and bring it to a boil. Have you ever heard that a watched pot never boils? Look away. Alright, now that it's boiling, be extra careful. Try not to splatter and avoid getting too close to the steam. But you can get your first cup of sugar ready, and we're going to mix in about 1/4 cup of sugar at a time. It doesn't have to be precise though. Just pour a little in and stir gently until all the sugar grains disappear. You can keep mixing in the sugar until you've added both cups. Each time, notice that the water gets thicker and that it takes longer and longer for the sugar to get incorporated. Normally water can't hold this much sugar, but since they're both really hot right now, we can make what's called a supersaturated solution. After the water cools back down and sits over the next week or so, the sugar comes back out of the solution to form the sugar crystal candy on the stick. Once you have all your sugar dissolved, remove it from heat and let it cool down for about 20 minutes. While it's cooling, dip the stick in the sugar solution and roll it in some sugar to help jumpstart the crystal growth. This is like how Ian used sand and pebbles. After the 20 minutes have passed, have your friendly grown-up pour the sugar solution into the jar. And I'm sorry I forgot to show this part, but add food coloring here if you want, and hang the stick back into the glass with the clothespin that you set up earlier. Put it somewhere it won't be disturbed, and then wait for your sugar crystals to grow over the next few days. When you're ready to take it out, the solution might still be a little gooey, so let it drip dry on a plate for at least 30 minutes. After that though, the sugar crystal candy is yours to enjoy. Did it turn out how you expected?
Well, my experiment didn't turn out exactly as big or as purple as I had hoped, but that's okay. What do you think I should try differently next time? Maybe I could add more sugar to the supersaturated solution, or I could let it grow longer than a week. I'll definitely use more food coloring next time. If you try this experiment at home, post a picture and show us how yours turned out. I'm gonna eat my candy now.
In Big Rock Candy Mountain, you never change your socks, and little sweet of lemonade come trickling down the rocks. The people there are friendly, there sometimes every day. Oh, I'm bound to go where there ain't no snow in the Big Rock Candy Mountains. Big Rock Candy Mountain.
Hi, it's Angela, and I'm inside a crystal cave at Garner State Park.
Garner State Park is one of Texas' 80 state parks, and it is west of San Antonio. I got to ask Shaylee Burns, the park interpreter at Garner State Park, a few questions about Crystal Cave. She said most of the park is underlain by Cretaceous age limestone. That's a 145 million year old rock. you can hike up to the upper slopes of the park, and that's where you'll find Crystal Cave. Crystal Cave is considered a live, active cavern, meaning that water still drips, etching and creating typical cavern formations like stalagmites, stalactites, and columns. It is called Crystal Cave because of the large quantities of calcite mineral deposits, crystals. If you get to visit, use your eyes but not your fingers. Touching the crystals can damage them. And be on the lookout for cave toads and other critters.
Nice. Take a closer look at this cave ceiling. How is it different from the ceiling in the room you are in? Well, you probably don't have spikes coming out of your ceiling, I hope. These spikes, or icicle shapes, form in underground caves. When it rains, the water travels through the ground and drips from the ceiling of the cave, and every one of those drops is a tiny calcite crystal. When it dries, it leaves the calcite crystal there, and over time, they build up to make these formations called stalactites. It takes a long time for these to grow. It takes 1,000 years just to grow 10 centimeters. But what happens on the cave floor? The waterfalls there too. Look at this cool calcite crystal formation. They are almost touching. The calcite formation on the floor are called stalagmites. Stalactites, stalagmites. They sound almost the same. That is confusing. I don't want to mix this up though. Does anyone know of a way to remember which is which? Take a closer look at this cave ceiling. How is it different from the ceiling in the room you are in? Well, you probably don't have spikes coming out of your ceiling, I hope. These spikes, or icicle shapes, form in underground caves. When it rains, the water travels through the ground and drips from the ceiling of the cave, and every one of those drops is a tiny calcite crystal. When it dries, it leaves the calcite crystal there, and over time, they build up to make these formations called stalactites. It takes a long time for these to grow. It takes 1,000 years just to grow 10 centimeters. But what happens on the cave floor? The waterfalls there too. Look at this cool calcite crystal formation. They are almost touching. The calcite formation on the floor are called stalagmites. Stalactites, stalagmites. They sound almost the same. That is confusing. I don't want to mix this up though. Does anyone know of a way to remember which is which?
Like Emily said, stalactites sound a lot like stalagmites. To help you remember which calcite crystal formation grows on the ceiling and which one grows on the ground, look at how they're spelled. Stalactites has a C in it. C like Christina. Just kidding, C like ceiling. And stalagmites has a G in it. G like ground. Stalactites, stalagmites. Stalactites, stalagmites. Stalactites, stalagmites.
If you like digging in the dirt and picking up rocks that you see on the ground, then you might want to become a geologist when you grow up. A geologist is a scientist who studies rocks, also known as planet Earth. Geologists collect samples of rocks, soil, and fossils from dinosaurs from all over the world, and they also measure the impact of natural disasters like floods and earthquakes. If you would like to become a geologist when you grow up, hunt for cool rocks and learn more about the environment that helped them grow. And practice math and science, and practice how to read and create maps. If you like caves and don't mind crawling and squeezing through tight spots, then you should become a speleologist. A speleologist is a person who studies caves. These scientists study how caves are formed. They learn about animals and organisms that live in caves, and they also study things like stalactites and stalagmites. Some speleologists even explore caves to create maps that splunkers, or people who like to explore caves as a hobby, can use to safely tour a cave. If you would like to be a speleologist, practice math and science, and be really okay with crawling and climbing in tight, hot and cold spaces.
Look at that stalactite. Look at that stalagmite. That column over there, I bet took probably 1,000,000 years to make. I really didn't want to go spelunking, but my friends kept asking and I eventually caved. Gotcha.
So far we've talked a lot about crystals of all kinds, but now let's talk about a gem. A gemstone, or gem, is a piece of mineral crystal, which in a cut, polished form is used to make jewelry or other adornments. An example of these would be diamonds, rubies, sapphires, and emeralds. We call these precious stones. These crystals are found deep in the ground and have been mined to bring them up to the surface. When a mineral crystal is brought out of the ground, it looks very different than the final product. That's because the diamond shape we're accustomed to doesn't happen naturally. In its natural form, it's just a hunk of crystal. A lapidary, that's what we call someone who cuts gems, will take that hunk of crystal and cut it in very precise ways. They have trained a lot on how best to cut the crystal to highlight many factors such as its clarity and its color. They use tools like saws and grinders to form the final shape of the gem. Ta-da! The final product is stunning, don't you think? Here's a bonus fact for you. Some gems fluoresce under UV light. Take the Hope diamond for instance. Under a normal light, it's a brilliant blue diamond surrounded by white diamonds. However, under a UV light, it glows red and one of the diamonds around it glows blue. Scientists aren't exactly sure why the Hope diamond glows red, but they think it has to do something with the boron and nitrogen molecules that make up this diamond.
There's a little known semi-precious gemstone that's only found in China that dwarfs all of the other gemstones. They call it a luminous pearl. They're made out of a very rare mineral that glows in the dark. The largest one looks like this huge green pearl. It weighs 6 tons. That's about as big as an elephant, or 340,194 chicken nuggets. It kind of looks like this green screen. Wait, no!
Wow, that was sure a big gem. For those of you who love gems but don't want to spend the money on real gems, here's a fun and free resource. It's paperkawaii.com. Here you can print out templates and fold your own paper gems. Let's try it. So here I have my template printed out. All I'm going to need is the template, some scissors, and a glue stick. And it's optional, you can color it if you want. Ready? Here you go. I was always that kid that didn't color in the lines, especially if I'm going to cut it out. Next, we're going to cut it. So let's go ahead and get it cut. Remember, the solid lines is where you cut, and then the dotted lines is where you crease. And let's cut it. Alright, it's cut. And finally, we're going to fold it. And we're going to fold along all of these little lines, these dotted lines. And next, what we're going to do is find all of the tabs, and we're going to glue it together. And there we have it, a fun crystal. Can you try and make some of your own? Here's the website link where you can download your own free paper gem templates.
What does your birthstone say about you? Nothing, because gems can't talk.
Did you know that snowflakes create glaciers and icebergs, and that both of those objects are actually giant crystals? All of the weight and pressure of the snow cause the ice to compact together, and a glacier begins to form underneath the top layer of snow. Then the ice gets really heavy and gravity begins to pull the glacier down. You can find a glacier on every continent, and they can grow to be 60 miles long and 15,000 feet tall. Now, an iceberg is a large chunk of ice that breaks off a glacier, and in order for the ice to be called an iceberg, it has to be at least 16 feet above sea level and at least 164 feet thick. And yes, an iceberg is what sank the Titanic. Who would think the formation so massive could form from a tiny crystal snowflake?
Wouldn't it be cool to be like Elsa and create your own ice crystals? Just like that? You can create your own super cool crystals too. All you're gonna need is some purified water, a freezer, and 2.5 hours of patience. So the first thing you wanna do is carefully put some purified water in different compartments in your freezer. We're doing this just in case one water bottle doesn't work. Next, we're gonna set our timer to 2.5 hours. And whatever you do, it's gonna be really hard, but try not to open your freezer until the timer goes off. It doesn't take much to set off the super cooling effect, so be very careful when you're taking it out of the freezer. Regular water freezes when it's cooled below 0 degrees Celsius or 32 degrees Fahrenheit and forms ice crystals. But purified water has fewer imperfections, so it gets stuck as a liquid even when it's supposed to freeze. This will happen until something comes to interrupt it and sets off the growth of crystals. Pretty cool, huh?
Crystals are spiraling in frozen fractals all around.
We hope you enjoyed today's show on crystal science. The fun doesn't stop here. If you are interested in fiction books, check out the Crystal Door trilogy. It is filled with ancient crystal magic. If you are interested in earth science non-fiction books, check out Geology Lab for Kids. This book is filled with 52 projects to explore rocks, gems, geodes, and our favorite, crystals. Another great resource is to check out the Smithsonian National Museum of Natural History. Did you know that you can do a virtual walkthrough of their museum from the comfort of your home? As always, the Fort Worth Public Library is here to help you learn, dream, and do. Go forth and have fun!
Crystals are so cool. See you next time.